Ambitious architectural projects are often difficult to map onto the complex reality of the ground. Such was the case for the University of Hertfordshire's new student union building, the Hutton Hub. Could an innovative approach provide the solution to allow this vision to become a reality? Stay tuned to find out. This is IAM News, bringing you the very latest in infrastructure asset management. I'm Iphigenia, welcome. This distinctive glass facade to the proposed Hutton Hub building had low tolerance to potential building distortion, which placed a tight limit on differential settlement of the foundation. Initially, designers wanted to satisfy this by using a stiff raft foundation on the underlying weathered chalk rock. In simple terms, a raft foundation is a large flat slab that extends over the entire area of the building footprint, distributing the building's load more evenly across the soil beneath it. This would have kept differential settlements and distortions within acceptable limits and protected the brittle glass facade from damage. However, the plans hit a snag. Site investigations encountered a vast network of solution and mining features covering most of the building footprint and with depths of up to 25 meters. The infill to these features varied significantly from soft spots of clay to dense sand. Other areas of the building footprint comprise intact chalk. Basically, these were just about the worst possible ground conditions for differential settlement. Conventional settlement calculations, which cannot handle such variability, were overly conservative and predicted large settlements that exceeded acceptable limits. And since the infill volume was too great for ground improvement, project designers recommended to use piled foundations, which came with a significantly bigger price tag. This sounds like a job for more advanced geotechnical analysis. The site had already been extensively investigated in multiple phases using various techniques. So geotechnical engineers started by studying all this information in order to map the chalk and infill accurately in 3 dimensions. Geotechnical 3D FEA is one of the few techniques that can handle the soil structure interaction analysis of a raft foundation on ground with such high variability in 3 dimensions. So the mapped infill geometry was transferred to such a model of the raft foundation and supporting ground. The model also included shear and core walls to add their stiffening effect, and the structural loads were simulated. It was found that the raft was able to span the soft spots in the infill, and the predicted differential settlements were very much lower than those of the conventional analysis. The values fell within acceptable limits after all. These findings were reaffirmed by INSAR analysis data that showed less than 3 millimeters of settlement in the 18 months after construction. Not only was the option of a raft slab deemed feasible, but the design could be optimized with the raft bending moment and spring stiffness values for different options taken into account. And the result? A saving of £1 million versus the cost of unplanned foundation piling. Well, I'll take 10% of that, guys. 1%? You'll be watching IAM News. Join us next time.